So in the last videos, we started one topic called sorting algorithms. So 50% of sorting algorithms I already covered, sir. Okay. So I mean 50% of our syllabus, like basics of sorting and various cases in customized sorting. Sir, I want to implement my own sorting technique. For that, there are some predefined sorting algorithms are there, like bubble sort, selection sort, insertion sort, and so on. But anyway, those things I am going to cover from Monday onwards. Okay. So today I am going to start another topic. Okay. Today I am going to start another topic. So this topic I already covered for the existing batch students. That's why whatever concepts I covered for them, up to that I am going to cover for you people. So what is that concept is recursive, recursive recursive algorithms, or we can also call it as recursion. Sir, I can say it is the very important topic in DSA, because if you have a clear clarity how method calls are going to be happen, then only you can able to understand the flow of control, whether you are taking backtracking or anything, sir. But a basic idea of recursion must be required. So to understand this, first I'm going to take one example program. I need response from your side also for the output of this particular program. Okay. So consider there is one simple Java program is there with the name test. Sir, if I run this program, first let me compile this code. Sir, is the program is going to compile fine or not? Yes, because there is no mistakes, right? The program is going to compile fine. And if you run the program, you can see the output what we are going to get is hello world. Sir, up to this, do you have any queries?
No, sir.
Everyone please respond. Up to this, any queries?
No, sir.
Right. So now I want to add some functions here. Like I am declaring one function, I mean one method with the name method1. It is not receiving any parameters and it is printing some message saying, so method 1 execution started. Like this I am printing some message. Similarly, method 1 execution ended. Like this I have taken. And similar to this, in the main method also, I am printing main method execution started, main method execution ended. Like this I have. So you can see there are two methods are there here. There are two methods are there here. Now my question is, if I execute this program, what is the output you are going to get, friends? Please confirm.
Line number 10 and 11.
Yes, line number 10 and 11. That fifth line, sixth line never gets executed. Why? Because it is a method, right? Whenever you are making a call, then only that method is going to get a chance. Okay, if you want, you can see only main method execution started, main method execution ended. Like that, it is printing. Now my question is, sir, after this line, I am trying to call method 1. Now what is the output, sir? Everyone please confirm what is the output?
Line number 10 is executed and 5, 6 is executed and then 12 is executed.
Right. So first what will happen? Line number um, 10 is going to be executed. Then we are calling another method. So the control will go from this main method to method 1 body. Here, is there any other method calls? No. Simply these two lines are going to be executed. That's all. Now what I am going to do is, internally what will happen? We have to see. Sir, internally there is one data structure with the name stack. There is one data structure with the name stack. So internally it is going to create this data structure, sir. Okay, internally it is going to create this data structure. So to maintain method calls, JVM is going to create this stack data structure. Sir, what is the purpose? Listen step by step. I won't repeat second time. Listen step by step. So first JVM is going to call main method. So that main method entry will be there in the stack, sir. Main method entry will be there. Now main method contains three instructions. Sir, what is the first instruction? It is a normal SOP. It will execute. Then what is the second instruction? Sir, it is a method call. So we need to navigate to some other method, right? Yes. In such cases, to which method you want to navigate, that method entry also will be there in the stack, sir. That method entry also will be stored in the stack. Now what will happen? Sir, that method is going to get a chance. So this is the first line, this is the second line, this is the third line which is going to execute. Sir, is it calling any other methods? No, it is not calling any other methods. Sir, from main to this method we came, right? So there is no other instructions or method one. That entry will be deleted in the stack by JVM. JVM is going to delete that entry, and it will come back. It will come back. Sir, to where? From which method this M1 made the call, to that method it will come, which is nothing but main. Sir, main method contains three instructions, two executed. Any other instruction? Yes. This line will be executed next. After this, it will delete this main entry also, and it will report to the JVM saying my stack is completed. You can delete this stack entry, like that. So I hope everyone got clarity about this. Sir, any doubt how the method calls are happening here? Please confirm.
So that println is also method now, sir. It won't be there in the start.
It won't be there in the stack, sir. Don't go in depth, sir, because
Oh,
println at that line only it will execute, right?
okay. Yeah.
Clear, everyone? Please confirm.
Yes, sir.
Now, so let me check really is our expected output is coming or not. Let us compile this Java program. Program compiles fine. Let us execute. You can see main method execution started. Method 1 execution started. Method 1 execution ended. Main method execution ended. Like that. So all the four instructions are executed here. Like this we have. Next. So what is the next thing here is example. What is the example here is? Sir, observe carefully. I already added one method, right? I want to add one more method, like method 2. Next here I am going to take method 2. So now let us see how the flow of control is going to be happen. Later I will execute that. Now have a look once. Sir, is the stack is going to be created for this or not? Yes, definitely one stack it will create. So what is the first entry inside this stack? Sir, first JVM is going to call main method. So it will execute all the instructions. This is the first line which is going to be printed. Then second instruction, it is calling method 1, sir. So main method is calling which method? Method M1. Now it will start executing. Sir, this is the second line to be printed. Now, is there any other SOP? Yes, but before that, it is navigating to some other method. Now, what will happen? Sir, in method 2, so only 2 lines. There is no other method to call. So, hence, this is the third line and this is the fourth line. After that, nothing is there in method 2. This entry will be deleted from the stack entry and it will come back. Then in method 1, one line executed, another line is a function call, right? Now that function call completed. Now this line is going to get a chance. That entry also will be deleted and reporting to the main. In main method, we have one pending instruction. That instruction will be executed and this entire stack is eligible for garbage collector. Sir, really is it working? If you want, let me check by executing the program. You can see main method execution started. From that method 1 execution started. From that method 2 execution started. From that method 2 execution ended. From that method 1 execution ended. From that main method execution ended. Like that we are getting. Sir, do you have any queries up to this? Is the
No,
concept
sir.
is clear, friends? Everyone? Sir, everyone clear?
Yes.
Right. So don't worry, Sir is taking in depth, but I want to introduce one more method here. Last method. What is that method is M3. Because how the flow of control is happening, you should understand, because the next total cinema is going to be depending on this structure only. So those who got confusion, now please listen one more time. Sir, first what will happen? One stack it is going to be created. Who is going to create this stack? Java virtual machine is going to create this stack. Now inside this, what will happen? Sir, first JVM is going to call which method? Main method. So main method entry will be stored inside stack. Then it will print main method execution started. Then main method is calling some other method labeled with M1. So now in M1, this is the second line. But M1 is navigating to second method, right? What is that method? M2. Now it will print the methods present in M2. Then M2 is going to call another method called M3. Now it is going to execute. Sir, any other method calls? No. So this is the fifth line and a total M3 completed. Then come back. M2 pending instruction is there. Let us execute that and delete this entry. Next in M1, so we need to print this and delete this. Next it will come back and it will print main method and it will delete this entry. Like that, the method calls are going to be happened. Clear, friends? Everyone, the flow. Everyone got the clarity how the flow is happening.
Yes, sir.
Now let me check really is it working or not. Now you can see, sir, it is keep on calling. Sir, why? Because maybe there is some bug. What is that bug? Sir, we have to call method 3, right? Not method 2. Now you can see main method execution started. Method 1 execution started. Method 2 execution started. Method 3 execution started. Method 3 execution ended. Method 2 execution ended. Method 1 execution ended. Main method execution is also ended. Like that we have. Sir, everyone got the clarity of this output? Please confirm. Clear, everyone? Please confirm.
Yes, sir.
Right. Sir, if everyone clear with these points, whatever I covered? Of course, some people may feel like, sir, it is a known topic only. Yes, it is the known topic only, but there is some conclusions we need to talk with respect to this. Some points I am going to define, sir. What is the first point is, sir, a method can call another method. Yes, we have a clear instructions, right? Previously, a method we can call another method. There is no problem. Now, sir, a method can call same method also. Nothing will be creating any issue, sir. A method can call same method also. No problem. Okay. Next point, sir, a method which is called by a method which is called by itself, a method which is called by itself is called as recursive method. Sorry, if a method is calling same method again, that method is called as what? Recursive method. And this process is called as recursion. Sir, that entire process is there, right? That process is called as what? Recursion. Sir, a method can call another method. Okay, so the method can call same method also. So a method which is calling the same method is called as what? Recursion. Now, recursion always leads to stack overflow error. Sir, it is a runtime error. Sir, why? Because, sir, previously we created one stack, right? Let us see. I created one stack like this. First I am calling main method. So main method is calling some method like m. That m method is calling same method m. That m is calling same method m. Sir, it is infinite calls will be stored, right? My stack is going to be full. That's why recursion always leads to what? Stack overflow error. Then, sir, I want to stop that. So if we want to stop this, then we have to use a proper some special condition to stop this. What is that special condition? That special condition is called as what? Base condition. I am going to cover minimum 20 to 25 examples where you will get a clarity. So how you can able to write the base condition up to this? Do you have any queries?
No, sir.
Everyone clear with these basic points? Sir, other people are sleeping. Please respond. Now, so the next one is, let me give some examples for this recursion. What I am taking is one main method I am taking. This main method is calling one method m, and inside that method m, I am printing some message called good evening. I am printing some message called good evening, and it is a never ending process. It is a never ending process. Continuously it is going to be printed, sir. If you want, you can see. Sir, really, is it stack overflow is coming? Yes, my stack is keep on. 1 second, there is some mistake. Sir, in this method, we need to call the same method. Okay. Now see what will happen. Sir, recursively keep on it is calling, sir. Until how much time? There is some runtime error. Up to some runtime error, it will print. If you want, you can see how many lines got printed here. At certain point it is going to print there is some stack overflow error, like that. At certain point it is going to print. Sir, where it is there? Let me show you that error. Yes, you can see here. So have you observed? It is a runtime error which is present in java.lang.stack overflow. In that, this particular concept came. Sir, then some people may have a doubt. When we can go for recursion? Very simple, sir. If we have, if you have a common pattern, if you have a common pattern, then only better, then only better to go for which concept? Recursion. If there is any common pattern, you need to identify that pattern. It is vary from application to application. Suppose consider one simple example I am taking. Like I want to calculate addition of n natural numbers, sum of n natural numbers, like 1 plus 3 plus 1 plus 2 plus 3 plus 4 plus 5 plus and so on n. Sir, to calculate this, first I will do 1 plus 2. Whatever result I am getting, so that is nothing but I am considering as a plus 3 plus 4 plus 5. Have you observed? Whatever concept we used for the first case, same concept only, right? So again, this a plus 3 I am considering as nothing but what? B. Then that b plus 4 I am considering as a c. Then that c plus 5 I am considering as a d. Then this total thing I am going to consider as a E. Have you observed? One by one, step by step, we divided a big problem into small problems, and we are solving that small problems individually. If it is our requirement, then blindly we should go for recursion. Of course there are some problems also there, but how to overcome those problems, step by step I will explain. Sir, do you have any queries up to this? Please confirm. Sir, everyone clear up to this?
Yes, sir.
Right. So there are some three different cases are there, sir. So first case I am talking. What is the first case? Sir, based on number of method calls. So we have two types. We have two types of recursion is available. Sir, based on number of method calls. Sir, how many method calls you are making? Based on that, two types of recursions are there. The first one is called as infinite recursion. That means it never ends. Second one is nothing but what? Finite recursion. If you want an example for infinite recursion, we can take this previous example for infinite recursion. Sir, is it possible to convert that into finite recursion? Yes, with a diagram I will explain. Please listen carefully. Sir, how many times you need this message? Suppose for example, I want to print this message 4 times. Then better to give that number here like 4. Now what happens? Sir, this method is receiving one parameter, right? Let us take that parameter as x. Sir, I will print good evening. Observe my diagram, sir. I am going to take the diagram like we are calling a method by passing a number called 4. What is happening? Sir, two instructions are there. What is the first instruction? It is printing a message called good evening. After that, I am calling the same method with not 4, with 4 minus 1, that is 3. So next parameter is nothing but what? X minus 1. So next what will happen? Same pattern, right? Again it is going to be called here. Okay, since x value is 3, it will print good evening, and it is going to take m of 2. Second time it is going to call. Now it will print good evening, and again it is going to call for m of 1. So good evening it is going to print and m of 0. Have you observed how many times your requirement? 4 times. First time, second time, third time, fourth time. So whenever we got 0, we can stop. That is nothing but a base condition, sir. If x is equal to 0, simply I am going to use the statement called return. Return means what? Return is the keyword used in functions to come out from that function or to come out from that method. We are using this. I hope this diagram is very clear for everyone. Understood, friends? Please confirm. Everyone got clarity?
Yes.
Now let me execute. Sir, really? Is it generating finite recursive calls? Yes. Good evening message is printed how many times? 4 times. Okay. This is nothing but what is mean by finite recursion. Sir, let me copy paste the same example again because I want to talk about one special definition. What is that condition? Base condition. Sir, what is mean by base condition? See, to terminate recursive process, so we have to supply an explicit, okay, an explicit condition. So while defining the function, we have to give some explicit condition. Okay, this condition is called as what? Base condition. This condition is called as what? Base condition. And it is mandatory to provide base condition for good recursion. So if you want to implement a better recursion, while writing the code, you have to think and you need to write for the base condition. Okay, so I hope on the stop what is mean by base condition also it is clear for you. Correct, friends? Please confirm. Sir, everyone feeling comfortable up to this? Please confirm.
Yes, sir.
Yes, sir.
Right. Next, we need to talk about another case. What is the second case here is, sir, based on number of methods. So we have two types. Okay, we have two types of recursions are there based on number of methods. So what is the first one is direct recursion. So what is the second one? Sir, indirect recursion. Let me see what is mean by direct recursion. Directly, I am not taking any program. Just I will explain the sample cases, friends. So what is mean by direct recursion? In the sense, I am taking void m here. So inside this, there are certain instructions are there, and again I am calling the same method. So a method which is called by same method, of course it is the recursion. In that, at very top level, this one is called as what? Direct recursion. What is the second one? Indirect recursion. Sir, I have method m1 is there, so which is having some sequence of instructions here. After that I am calling method 2, sir. And I have second method is there. Inside this second method, we have some instructions. After that I am calling m1, sir. Have you observed? M1 method is calling m2, m2 is calling m1. It is a never ending process. Okay, I hope everyone got clarity up to this. Any questions? Clear, everyone?
Sir, then how we need to define the base condition in indirect recursion?
In both methods we have to define. There are some scenarios in future we are going to cover applications, there you will get these kind of things, but just assume syntactically.
Okay, sir.
That's why you people are going to get confused, right? That's why you need to remember that stack diagram, because if you have a clear clarity on that stack, you will get clarity. Okay, sir, clear, everyone? Please confirm.
Yes, sir.
Right. So that's all, friends. With this I am going to stop today. Sir, we have around 25 applications are there on this recursion. So our tomorrow's class, day after tomorrow, these 2 days I am going to spend by taking 1 hour time, like 8:30 to 9:30 full-fledged. So I am going to complete these recursion applications. So next week you will be having two things, sir. One is nothing but, so where I left that what you can call sorting. So bubble sort, selection sort, insertion sort, so quick sort, merge sort, these sorting techniques I am going to discuss. And after that there is one topic called backtracking. So it is a continuation of recursion. So the people who don't have any idea on recursion, those who are going to miss the next class, next two classes or three classes, so they can't understand what is backtracking, because I am going to explain the realistic problems like um, n queens problem and also sudoku problem. It takes minimum 1 hour 15 minutes like that to demonstrate. So don't miss remaining 2 days sessions. Okay guys.
Sir, can you go up, sir? The base condition you are explaining, let's see. Sir, can you explain with the stack diagram how the method is closing from the stacks?
See, very simple. A stack
Yeah.
will be created here. So
Okay.
first main method is there. Okay, let me start from method. Method 4, right? It is calling another method. What is the method? Same method. What is the parameter 3? It is calling
Okay.
another method, same method with the
Okay.
parameter 2. It is calling another method, m of 1. It is
Okay.
calling another method, m of 0. Is it going to call another method? No, because whenever it is calling, when x is equal to 0, what we are doing? We are stopping. So it will
Okay.
stop, it will come back. Is there any pending instructions? It will execute.
Okay.
No.
Yes.
There
Thanks.
is one important topic is there, sir, that I am going to start tomorrow. That is nothing but a tail and a non-tail recursion. It is a heart of recursion. So majority of students, they don't know about this tail and non-tail recursions. So tomorrow we will see. Okay.
Hello, sir.
Yes.
Sir, I made a today evening payment for this course. Then where I get the class notes.
Sir,
Yes.
till now I have not given access for class notes, sir. So once if all the payments got completed, once if our regular class started, I will give. Maybe tomorrow or day after tomorrow I will give. Okay.
Okay, sure.
Yeah. Right guys, thank you for attending these demos. Thank you.